In this video, I'm going to cover the concept of sketching transformations with instructions. So you've actually already done something like this before, but I'm going to highlight in more detail now. So let me do this with an example. Okay. So let's say example 1, and it's the following. So let's say if I have a parent function for the quadratic, so it's f of x equals x squared, and I transform it to some function called g of x, but I don't tell you what g of x is. Instead, what I do is I give you a list of instructions, or in other words, a list of transformations to go from f to g. All right? So for example, in this case, in order to go from f to g, first I must reflect across the x-axis. Then secondly, I stretch in the y direction by a factor of 2. I'm just going to write it by 2 because I'm running out of space there. And then finally, I'm going to translate by this vector, -2, -4, which of course means 2 to the left and down 4. All right, so this is the information I've given you, right? And the question is the following. There's actually 2 questions. So let me start with question A. The first question is, find an expression for g of x. All right, so in other words, we have to basically find an equation for g of x that's equal to something that's like a quadratic. So let's see how we can do that. All right, so we have this information here. So the first thing that we should do is basically write g of x, okay, and we have to write it in terms of f of x. Okay, so why in terms of f of x? Because these transformations are related to f of x. So we're going to deal with the x squared later, but first we're going to deal with f of x. So let's see how that works. So since g of x is some transformation of f of x, so here's f, and I'm going to put a bracket there, and we're going to fill this out as we go along. All right, so a reflection across the x-axis, which means it affects the y's, which means it's outside of f. So what that means is there's going to be a negative outside right here. So we've taken care of that. Then there's a stretch in the y direction by a factor of 2. So if it's stretch in the y direction, it means it's outside of f, not inside, and that's going to be 2 right there. So we've taken care of that. Then translate 2 to the left. All right, so there's no horizontal stretch, so we don't have to worry about writing some number inside here because there's no horizontal stretch stated. So inside here, since it's 2 to the left, if you recall, we have to do the exact opposite, so it's going to be x plus 2. Remember, when we have a function and it's x plus 2, it means 2 to the left. And finally, it's 4 down, and that's going to be outside of the f, so it's going to be -4. All right? So we've taken care of the first part. In other words, we found sort of an expression of g of x in terms of f of x, but that's not what we want. We want things in terms of quadratic. If you write things in terms of f of x, f could be any function. But we know exactly what f of x is, and so we can write g of x specifically as an equation or a quadratic function. Now, so part 2 is we have to go from here to an actual function, right? So the key thing to remember here is that this function right here is f of x plus 2. So if you go to this equation, when we have f of x is equal to x squared, whatever number I put for x needs to be replaced here. So for example, if I had f of 1, this would equal to 1 squared. If I had f of 2, this would equal to 2 squared. F of 3, this is equal to 3 squared, and so on and so forth. But what happens that instead of a number, I have another expression. So if we observe over here, we have f of x plus 2. So in other words, if I replace this x right here with x plus 2, I also need to replace this over here with x plus 2. And so let's do that. So I'm just going to go back to the green. So this -2 stays on the outside, all right? And what I'm going to do right here is I'm going to replace this with x plus 2, which means this will end up being x plus 2 squared, right? All I've really done is I've replaced this x with x plus 2 because this is my parent function. And then, so I've taken care of this, And now let's not forget the minus 4. And ta-da, I have my expression for g of x. So g of x is equal to negative 2 x plus 2 squared minus 4. So that's step 1, and that's actually the first question. That was part A. Now part B says sketch the transformation from f of x to g of x. All right? Well, now that we have our function for f of x, this is actually really, really simple. We know that f of x is equal to x squared, and g of x, I'm going to go back to green, g of x, which we just determined, is negative 2 x plus 2 squared minus 4. And since we have that, now we can just sketch the transformations. So if I have my like a simple xy plot right here, well, this one is going to be a parabola, and this is x squared, and that's nothing hard about that. That's simply our parent function. And in case for this one, oops, let me just scroll back up a little bit. Let me just draw this set of axes. So obviously it's not very straight. Let me just try to make it straight if I can. All right, that's not very straight either, but you know, you get the idea. So in this case, the vertex is negative 2 and negative 4, and that's our point, and it's facing down. So that's basically it. So this was our original parent function, and we've transformed it to this, and now we're able to draw it. So the key thing I want to highlight here is really, the hard part is really the first question, right? The first question, which is find an expression for g of x, we have to take our instructions and translate them, or in other words, we have to put them into an equation in terms of f. So once we put them in terms of f, then we just take that f and then we replace it. You know, for example, if this is x plus 2, we replace that with x plus 2, and then boom, we have our quadratic equation. Once we have our quadratic equation, everything else is so simple. Sketching is just a cinch. It's a piece of cake. And so we have our quadratic function right here, and then we were able to draw the original. This is the transform function, and we're done. All right, in the next video, I'm just going to give you another example of the same thing.